Good morning, Kobe.
Oh, hi, Sammy. Good morning. How are you doing?
Good, good. How are you?
All right, good, good. Yeah, doing fine.
Yeah, today we will continue the discussion on uh,
Okay,
the fan and power cooling laws. And
sure.
next
Yeah.
next week, I would like to go and look at the schemas and what is available in the Redfish,
Yeah. Okay.
and we should map. I mean, at least kind of harvest all the info.
Okay.
And the following week, I'm kind of thinking we should really formulate the UEs and trying to
Sure. Yeah.
map it to
Okay.
what is missing, what is available, something like that.
Okay. Yeah, I can pull some of the attributes from the carbon index calculation from my model, which I did about a year and a half back.
Okay,
I'll pull
okay.
through some of the attributes and how we can kind of, put it back into the standard templates and schema, Yeah.
Sure, yeah.
Okay. Yeah.
Give a couple more minutes for
Sure. Yeah. 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 That's fine. Huh? Yeah, I'm running some benchmarks, in parallel, so hot for
Sure.
one other server. Yeah. And then also, like I don't remember, the one other person from HP kind of scanned through some of the schemas and all those stuff and all.
Right.
I didn't, because it was so quick, right? I'll look at it. And then also there is something, a power telemetry for each and every subsystem. Maybe good idea to include it. If it's already there, that's great, right? No issues.
Yeah.
And, so because using some of the commands like turbostat and other things and all, how can we get like, CPU, clocks, VDD, and other power, attributes. That's what I was thinking, right? So I'll look at that and see,
Yeah. I think what we should do is we should go and look at all the power related
Yeah.
attributes, whether
Right.
it's
Right.
system level, fan level, whatever it is, right?
Yeah.
Device
Yeah.
level,
Mhm.
anything that we can
Right.
harvest, right? I
Yeah.
think
Yeah.
we,
Definitely. Uh-huh.
yeah, we should bring all the things what is available, right?
Yeah.
Before even
Definitely.
looking at what is not, what need to be there, right?
Right. Yeah, exactly. Right.
But,
Because you need to do IUE from complete power perspective. What does it mean? All the devices need to report. Then we can say, okay, what is there not, and what do we need to add? Right? Yeah. That sounds good.
yeah, I think one of the things what I'm kind of after kind of started looking this one, right?
Mhm.
I'm wondering whether system level UE makes sense, or does it need to be rack level, right? Uh,
I think rack level would be a good decomposition to me, right?
right.
Because just by doing on a system, like equivalent of PV, it doesn't roll well, right? In the sense, it's hard. So you can do a decomposition of the IUE to maybe some other definition, but at a rack level will be I think, a nice thing to have. That way, even if it is a heterogeneous mix of servers, you're taking all of those into account in a way, right?
Yeah, I think that is one, but I'm also kind of thinking is so now if some people are contributing a system,
Mhm.
then we probably need to do a mapping. Assume it is
Sure.
populated in the rack homogeneously, right?
Right. Yeah.
So there's something like that we should come up with and say like, hey, now what is the system level if you're doing that, right?
Yeah. Sure.
Because system has a lot of sharing elements,
Yeah.
but it's you can still have a system level if you're really saying if it's
Yeah.
populated in this rack, right?
Right.
I don't know. So I think that is one. I think we need to figure out, right? How do we represent? But people are contributing system, right? It's not racks.
Yeah. Oh, no. Yeah. So I think it's good to have, you give it a rack level, double click on that, then
Right.
it gives the individual node level. And that way there is some kind of, translation in a way, Yeah, sure. Yeah, definitely.
Right.
Good point. I have quite a few things I modeled in mind. So, but anyhow, so I'll look at that and see, what is missing and all those stuff, Yeah. It's been a while since I looked at it. Yeah, and then also Mohan told me to look into some of the potential, right, customers who can do some measurements for us, maybe internal, external, I don't know. So I'm putting together a list of those, right? So to see, so what we can drive, as we move forward.
Right.
Looks like nobody has joined so far. Is the weather and all okay in Oregon now?
Yeah, we are back. I think it's raining.
Okay, good. Yeah. All right. I know it was pretty cold, right, last few weeks.
Right.
Here, we had a lot of snow, and then I think 4 or 5 inches. Everything is melted now, so pretty much back.
That's good. Even
Yeah.
we hear a lot of icy thing and a lot of trees fell down and a lot
Oh,
of
really?
people didn't have
Oh, okay.
power and it was kind of messy for a few days.
Sure. Yeah, okay. You live close to office or you're quite far?
No, about like up 20 minutes.
Oh,
away.
okay, not bad. Yeah, okay,
Yeah.
that's good. Yeah, for me it's quite a bit, almost 45 minutes drive,
Wow. Oh,
Yeah.
okay.
So, but I go a little late, or early, so that way I
Okay.
can work around, Yeah.
Right. How is the traffic over there generally? Like it's a
In the peak hour is bad as any city, right?
okay.
So, but if you get into DC, it's terrible, right? So, but I'm a little bit away from DC, is all right.
Outside. Okay.
Yeah. But when I go to agencies to meet folks, right?
Right.
Like DARPA and many other folks, then it is quite a bit traffic,
Okay. So we don't see people today, and maybe there's some other conflict going on.
Right. Yeah. So probably we can use the time to work and yeah.
Yeah. Let's start discussing a couple of things. I want to kind of start putting some birding around there, and so we can discuss it. So last week we kind of looked at ideal power, and we were kind of going through like what is that different things we need to look. I think we have a good handle on it.
Yeah, you generate a good list, right? Yeah, that's good.
So I will kind of go back, and after completing this discussion, I will summarize the things, right?
Okay.
And also we kind of started discussing the power. We have traditional rack and DC bus bar.
Right.
So in this one, the PSU shared between the systems. In the other case, you have a PSU per system, right?
Right. Yeah.
Right. So I'm kind of maybe we need to map this one to different variety of systems, right? Like for example, if I say like these systems, right? I assume, except do we have a if you go to the immersion cooling, right? Are we going to have a power supply per system, or is it shared?
I think if I remember in the pilot, what we have, right?
Right.
In one other side, they have per rack, it seems. They have immersed a half a rack or something like that, right? In a refrigerator, like a freezer, like, tank in
Right.
a way.
Right.
And then, of course, the commercial, implementation will vary based on the size and other things.
Right.
So, yeah, so I need to find out, how they have,
Yeah. So I think regardless of that, right, we should um, either it's going to be per system or it can be shared, right? Something like that, right?
Yeah,
You can assume for power related discussion, it is shared or a per system. That's all right.
I think it is per rack, so to
Okay.
my
Okay.
knowledge.
Okay.
I can double check,
Okay.
yeah.
Okay. So then I think going on the power loss, I think that's what we are after here, right?
Yes, yeah.
Non-IT power, right?
Mhm.
So if it is traditional rack, I should say traditional rack. Okay. Yeah, traditional DC bus power, right? So traditional rack, we have power supply and you have loss per power supply, right?
Right, yeah.
Which you can account to each system. So if you don't have a homogeneous, heterogeneous, maybe you have 2U rack and on you and for you, like it's all
Mixed up,
different
yeah.
power supply is going to be there, right?
Right, yeah.
So you
Yeah.
can say like loss per system
Mhm.
and also DC to DC converter loss per in each system. So it's a system level accounting and you're summing them together for a lack level, right?
Right, yeah. In my model, what I've done is I've taken per system,
Right.
assuming a homogeneous kind of deployment. If
Right.
it is heterogeneous, then I need to, do a summation of all the stuff to kind of, somehow calculate it and then sum it and then say per node it is so much and per rack is, so much, right? In a way,
Correct.
is a
Correct.
sigma
Right.
in a way.
Yeah.
Okay,
Yeah. Sigma, yeah.
that's easy to add,
Right.
yeah.
So now, if I want to say at a system level for DC bus bar,
Mhm.
so you have a common power supply loss,
Right.
and that loss is going to be distributed across all the
Yeah.
systems.
Systems, yeah. Mhm.
So I'm kind of thinking like we could at least assume the total TDP of power supply capacity is the total sigma of all the TDP max TDP, right?
Right. Uh-huh.
So if you assume that, then if you not for the loss purposes, you have a per system TDP, max TDP, I should say max TDP. Then your total power supply,
Right.
and if I divide this divided by the total, then that is a factor you get, right?
Yeah. Mhm. Sure.
And that factor you want to use for calculating per system loss.
Mhm.
But only thing is, assume it's all max power, then this factor looks good. But
Yeah.
if you're operating somewhere in the middle, right,
Right. Yeah.
it may not be linear, right? But
Yep. Sure.
just to simplify, I think we should assume it's linear, so that
Mhm.
otherwise, let us say if the system is operating at 50%, what is the factor, and 30%, what is the factor, ideal, what is the factor, all these
Yeah.
things will apply, right?
Right. Yeah. Now we can build a, like a curve, whatever it comes, then we'll have
Right.
an equation, loss is equal to X plus or minus some factor times, so much, right? So that way you can, use that equation to kind of calculate, right? We could do that too.
Right, but also even one system is operating ideal, another system operating max
Yeah,
TDP,
then
right?
sure. Yeah.
Then
Definitely.
how do you kind of put a factor there, right?
Right. Exactly. You have to
We,
calculate per each one of them.
right. So we could probably put it in a formula, but at least for a simplification purpose, we can say it's linear.
Yeah. Okay. Mhm.
And if we want to go make it complex, then we can put a formula, right?
Yeah.
So,
Right.
uh,
Yeah.
then it's going to be complex formula because each system depending on if it is a heterogeneous especially
Mhm.
things may look different, right? How much
Oh
power you
yeah.
are consuming and depending on the load factor of the rack, it may the DC bus may look different, right?
Yeah. Yeah, I think
So,
calculate per system and then add it up, right? That way it doesn't matter. It depends upon where each system power states are, whether
right.
idle to full load, max, whatever, right? Overclocking, you
Right.
can kind of, so take all those numbers.
Right.
Okay.
So what I'm saying is, if you want to say actual power loss, so for a system, but how much power is consumed,
Yeah.
and just multiply with the loss factor, right?
Yeah, that sounds good. Yeah.
Right. So we can basically simplify and say like, hey, if I
Yeah.
have a traditional system or DC bus power or shared power, still I can produce a power loss per system.
Yeah, perfect. Yeah,
Right.
that sounds good. Yeah.
And a DC power loss that is within the system, so that we accounted for.
Right. Yeah. Okay, that sounds good. Yeah.
So now I think power is taken care. Now look at the cooling, right? I didn't put a traditional. I think I should put a picture for traditional. Put up a fan. And you have a system, and you're going to have a chiller, and it's depending on how it is going to be circulated, right? I think interesting thing here, right?
Yeah, the CDU and all kinds of things. Okay.
Right. CDU, you can have per rack CDU.
Yeah.
Or in this case, you have fans within the servers, and also CDUs kind of outside. It's taking the power out of it, right?
Right. Yeah.
So now the question here is even this. Yeah, I think both are same. Even this one, if I go, you have a immersion tank, and there's a CDU goes to there, right?
Right. Yeah.
So in this both cases, I say there's a CDU. How do you want to account, right?
Sure.
In this case, is it this CDU can be shared across racks? Same thing here. Is the CDU can be shared across a rack or only per rack CDU?
Yeah, I think it varies, based on, type of systems and how many. For example, if you take a rack, in each node, for example, you may have 2 CPUs and then 8 GPUs or 16 or 32 or 64 GPUs and then some FPGAs. So you can have multitude of these things. So then based on what it is, the CDU may be per rack or multiple racks too. So we need to take both into account, how it is kind of, implemented. So it may be minimal. It will be, if they are running high power, say 32 GPUs, then you'll have definitely dedicated CDU per rack. And if it is only 4 of them, example, it can be the CDU can supply to multiple racks also. So we need to figure that out.
Yeah, so I think what I'm kind of looking for is this is like power supply calculation, right?
Yeah, right. Yeah.
It's within the rack, whatever that power is consumed for this.
Yeah.
We can divide it to a similar factor, right?
Yeah, I think so. Right. Yeah, definitely. Right. Yeah.
But if it is this way, CDU shared across multiple racks.
Yeah.
Then we need to put the boundary at a multiple rack level. What is the CDU boundary, right?
Yeah.
Then we need to divide similar to that max TDP and other things we were talking about it. We have to put a factor and say like, hey, per server, how much I need to take it from this common pool, right?
Right. Yeah, definitely. So we need to see what the CDU distribution is per rack consumption. We need to measure multiple other things, right, before we compute, right?
Right. So let me put one more file, right?
Yeah. I'll check into, what I'll do is I'll create some sample distribution models and then see what is just an example, I can pull through some data commercially available, implementations and then see how we can track, right? So we can kind of estimate that,
Yeah. Use factor similar to DC.
I think when we build this cooling and everything, you can take every type, active cooling, passive cooling, air cooling, water cooling,
Right.
and then right. So cryogenic and CDUs, and then also we can say immersion. So that way
Right.
we can have formulas for each one of these. So that way it's universally can be applied.
I think that is
Yeah,
once
I
we
think.
do this, then
Mhm.
all the three, right? Whatever the things you are using doesn't matter
Yeah.
what type of cooling, right? We just if CDU per rack is not there, that it becomes zero or null.
Yeah, that's
If
it.
it is
Yeah.
per rack, then it's one, or is it multiple, then you have to do the division of TDP, rack TDP, right?
Yeah.
And we need to put some similar factor there, right?
Yes. Yeah.
But again, here also we will run into the same problem where we were discussing on the DC bus bar, right?
Bus bar. Yeah. Right. Yeah.
Right.
That's true. Yeah.
Right. And here also PAN, it is shared across multiple servers, right?
Yeah.
Then we need to factor in, right? That one also, right?
Yeah. Heat exchanger. Yeah. That's true.
PAN is shared.
I think another thing maybe at some point, like heat exchanger, when say liquid goes in and then warm liquid comes out or air comes out, whatever the case may be, then how much amount of the heat reuse is used for maybe for building or air and other things that also need to be taken into account some way when you report out to the data center metric in a way, right?
Right. So another thing here, right? If I go back here, right? So in data center also you're going to have a chiller and other things, right?
Yeah.
In today there is a as part of PUE that there is a cool chiller and other cooling is part of data center cooling, right?
Yes.
Now here we are going to account per server per rack.
All right.
We need to make sure that we are not double counting,
Yeah.
right?
Yeah. Definitely.
Right.
Yes. Yeah. That's perfect. Yes. We have to.
Right.
Because when you calculate per rack, whether it is normal cooling or other specialized cooling methods, then it'll be rolled up in a way. So that way so we are not counting two times. Yeah, we need to ensure that.
I think that kind of
Yeah.
summarizes it. As long as we can put the factor, I think now the question again comes back, right? Is IUE at a system level or rack level, right?
I think to me is applied at both, in a way, like, we want to report at a data center level. And then also when they double click on that, you should be able to report at a rack level, right? R node level, some point, right? So there should be a roll up across top to the, data center to the node level.
Per system with suffix system, I don't know, traditional, right?
Yeah.
T or something like that. If I say our system, what do you call immersion?
Yeah. Because people have not deployed immersion on a wide range yet, right?
Right.
So that means you need to roll it up based on DC to rack to node,
Yeah, something like that, right?
Yeah.
So you cannot have one factor per system because unless the system is designed only that way, right?
Yeah, right. Exactly.
Then still you need to kind of do we want to indicate the type? I'm kind of wondering, right? If I have a let us say a set of processes, if it is operating on all these different conditions, right? The numbers may vary, right? That's what we want to highlight.
Sure.
Which is more efficient, or
right.
It's giving a better IUE. So we want to put a system and with some notation so that we know what we are really talking about, what type of system it is.
Yeah.
Then we know like IUE is for that system is much better or lower because depending on where you are operating, right?
Right. Yeah. Well, how I did was in my carbon index determination, I put together with a traditional cooling method and say for the rack, say 34 node system or 48, 42. And then I calculated what the PUE is. And then I say, hey, if I take the same thing and put it back into an immersion cooling, and then what is the carbon footprint emission? It came to be 15 to 22% lesser carbon footprint compared to the method one. So that's how I rolled up. So yeah, definitely. Yeah. Okay.
But we need to have some notation, right? So that people can immediately
definitely
figure out, right? Hey, I'm talking about a particular processor or a particular system.
Yes.
What type of cooling environment or power supply environment, right?
Yes. Yeah, definitely. Yeah.
Right. Or we need to have a definition if it is even we are talking about a system can have a this one, right? It's it can be common or somehow people can immediately identify
right. Yeah, definitely.
this particular type and here is a number for it.
Yeah. Yeah. That sounds good enough. Yeah.
So I think I will try to define notation and let's come back and review and make sure that we are does it make sense, right? We want to make sure that people can easily understand it, right?
Right. Yeah. At least come to the 0.8 revision level, then you can review, add missing things, and then that will help in defining the measurement methods and what all we need to do, as we move forward, right? So at least even before doing that, we can put a modeler, Excel spreadsheet modeler, and say, okay, yeah, this is how it comes out. Oh, we need to change, move around, whatever, we can discuss that. Then we can translate back into software, Yeah.
Right.
Okay, that sounds good,
Yeah. So then I think the other question, at least in the PU8 paper we said, how is WE is?
Oh, water usage effectiveness. Okay.
Comprehension in IUE, right?
Right. Yeah. Well, I need to look at a little bit more, So I know what WE is and what are the things which goes in, but how do we get those measurements and all those stuff, right? So
yeah,
there'll be quite a bit challenge.
In system level or only rack or DC level?
Yeah, I think I think similarly it needs to roll up from system to all the way to the DC in a way, right?
Right.
Yeah. So.
No, but I think WE, my understanding is it's at a data center level, right?
Yes.
So then,
but only sorry, only 4 racks in the data center may be using PVCs, for example, point VKO, and then with the water cooling system, liquid cooling, right? So then how do we, if you roll out a data center, people should not get a notion that whole data center is a liquid cooled or something. No, only partial, right?
Right.
10% of the infrastructure is liquid cooled or something. So we need to kind of, give a clear picture on what, they should not walk away stating that, oh, the whole data center is liquid cooled, right? So
Per system.
per system, per rack, right? So that's it, yeah. Probably if you move forward 3-4 years, then a lot of, smaller data center would have deployed latest cooling technologies. Then
Right.
it'll be easier to roll it up to even to DC level. At least if you contain for a system and rack, then
Good.
you can expand it. That's my thinking.
Right. Because when you are comparing, we should be able to say, if I say a system or rack, right?
Yeah.
This is going to be better for WE or lower for WE or whatnot, right?
Yeah. Right.
That need to come out of that comprehensive.
Sure. Yeah. Okay.
Right. What other things we were looking?
So did we get the next steps from the? Sorry, go ahead and finish this metrics, then we'll come back.
Yeah. So
global warming.
Yeah. So do we want to account anything in IEE system level with this?
CUE, yes, definitely. Carbon index utilization. We can model that. I have quite a bit done already, but we can look at it and see what other things need to be done. But GWP, I don't know. I never looked at it. Global warming, I don't know. It'll be just another translation, taking these base numbers and then building some algorithms and say, oh, this is what it is. That becomes so hard, right? How do you map each data center unless we feed in a lot of, right? Historical data, right? That'll be a hard one. That much I can say.
Right. Devices. For even CES embedded versus operational, right?
Yeah, this system per rack per data center you can roll up. That's pretty easy. Right? Because what I did was I downloaded for 50 years all the states in US, all the carbon emission per kilowatt hour, and then I mapped it back to the rack and then automatically pull in based on the power consumption. Right? I can go any deeper also, system to rack level to DC level. That is, that's pretty easy to do.
So, but yeah, embedded is easy. If we go with the operational one, again, depending on what power is provided, right? That is it going to change?
Yeah, so the one factor I did not include, we need to include is what is the input power? Where does it come? Is from through hydroelectric plant or solar or something else, coal? Those factors are not included. I was in the process of doing it. I never did that. So we need to take that also. What is the method in which the input energy is achieved? Right? Is it fuel cells or it can be hydroelectric plant or solar or wind, whatever it is, right? We need to factor all those stuff. Right? Makes sense?
Right.
So that way we'll get a true picture of the carbon, not just, okay, I used, 30 megawatts, you translate it on a particular geolocation, you can find out what the carbon footprint impact is. But if it comes from the fuel cells, then the amount will vary, carbon index. Or when it comes from true electricity grid, which can come from coal to steam to et cetera, that varies also. We need to kind of, include all those parameters in a way, right?
Yeah, but
at least we can identify. Yeah. Go ahead.
If we understand the power portion of it, then is it a factor that you apply? Like how much power is lost or once you calculate IUE,
right?
Is it a factor that you can just apply and for this operational one, and we can say does not. What I'm saying is, let us say if you say 50 megawatt or whatever it is number, right?
Yeah.
Depending on the energy input type, or per system level, you're going to say, I don't know, it's a 5,500 watts or something, right?
Mhm.
Then depending on energy type, is it automatically we can apply the factor and say this is how much is going to be the CE operation CE for it?
Yeah, I think we can roll it up at a data center level, rack level, and a node level. There's no
Right.
issue in Carbon, right?
Right.
But only factors will be outside of the data center. How the format of the power comes in, there may be some other reason out of the, we have some methods. We can introduce those. So, but we'll assume that a pure electricity comes in. How it comes in, let us not worry about it now, whether fuel cell, steam, coal, etc., etc. Then we can add those things later, right? So,
Right.
but from Carbon perspective, we should be able to track at a node level. Oh, I'm feeding in with the max configured GPU, CPUs, etc. I'm using 5,000 watts per node. Then I should say for this Virginia location at this carbon emission is so much, and then how much is that kind of? We should be able to correlate that, right?
Yeah. So does it change where we are operating to?
Change where operate. I mean,
The location geo?
yes. The carbon emission per state is different. All the 50 states, whatever states we have, the emission amount which has been factored over like 40 years is different from state to state.
Right. So
Yeah, I downloaded from the energy site, and then I'm using that, as a pivot table. Yeah.
For operational carbon,
Because the costs will vary also, right? In
right.
Virginia, it may be cheaper compared to Seattle or Oregon or somewhere else, right? Or California.
Right.
So,
So
on the
given all
emission.
these things,
Yeah.
Does it really useful put a CUE operation CUE for a system?
Yeah, I think
Or if
so.
you want to say it, then you need to say with all the factor, right? Does it need to include the geolocation? Does also need to include the energy type? Then only you can say operation CUE carbon, right?
Right. No, per system will roll it up, but
Right.
because we'll take pure power which comes
Right.
into the data center. That's about it.
Correct.
But how it comes in, let us not worry. Maybe at this point, we'll define it later. Like embodied carbon, all those things, right? So I think
From power, one could determine operational carbon.
because some of the folks,
based on-
who are data center near the ocean, they run the pipe deep into the water where the water is cold and they use it. So for them, the carbon, is totally different, much lesser, right? Compared to the how operating in a downtown Seattle or somewhere else, right? So
Right.
yeah, I was about to do the translation. I stopped, a year and a half back, so
Right.
it's
I
so
think
much in. Yeah.
as long as we understand the power and geo or
Yeah. Right.
cooling, right?
Yeah.
Power and cooling both, right? Energy type and
Yeah. And then also I have some customer level data when I used to work with them, where I optimized the 30 megawatt data center. And they use Bloom Energy technology, which is the fuel cells. That's the first energy, first level energy. Second is the transformer. Third level is the Utah electricity grid, for example. So there's the backup, different thing. So for each one of them, the PUE was different because, right? So anyhow, so they were always trying to run only on fuel cells.
Okay. So I think then IUE we should probably just say with the power, not really like trying to tie with all the types here, right?
Right. Yeah. Yes.
And people always can take the power and go and determine what is this other things, and you can really calculate their PE out of it.
Right. Yeah. Yeah, that's good,
Right.
have some.
And what is the other one? Going back onto the type. How did I have this? Energy reuse. Yeah, very good.
Which one is it?
Says GWP.
Oh, right. Yeah, I don't know much about it. I know what it is, but I don't know. I've not seen any modeling in that perspective. How do we translate back into? So we need to look at the EPA, Environmental Protection Agency, the metrics and standards and global warming data. Then we see, okay, if we use so many gigawatts in a geolocation, what does it mean to, right? I don't know. So I need to
Yeah, I
to
think just
understand a little bit.
watts and also like for liquid cooling, right? It based on what liquid you use, that also you need to get the liquid, right?
Yeah, right. Yeah.
There is things involved, and yeah, maybe we should figure out and put some numbers, right? If it is
Right. Yeah. Even in the liquid cooling, right, there are different kind of, for example, immersion cooling, right? Different types of electrolytes are there, right?
Right.
So, and that plays a different role. When in the global warming picture aspect of it, let me read through, so I need to learn a little bit more, so what we need to. Is this a new metric which they came out? I've not seen. I've seen only CU, W, water usage effectiveness, and DCE, IUE now, and then etc. Global warming, I don't know. Maybe these green grid people may know. I'm not sure. So if they have defined anything.
Outcome for the plus, I will just say.
Yeah, I think there is some agency, sorry, publishes this global warming, they track and publish, but I don't know how they publish it as. Do they translate back into, okay, there is huge chemical industries, or they're contributing, impacting the environment, those kind of things. And if you say if data centers are consuming 7% of the world's electricity, there are a lot of numbers available. So we need to look at it to see how we can kind of map it back to that, right? To say that here is the GW impact or so, right?
Yeah. So I think what I was again going back on looking at it, right? If I want to put a system or a server or rack, we want to put that as part of that so that it's all comprehensive, right?
Yeah, sure. Yeah. Good point. Yeah. Okay.
I think that's all I had. You had some question? Sorry.
Oh, no. I think I'll hold on to that, so let me do some research on that, so yeah. Yeah, I think it is good, so I think if we can finalize this list, and then we can start taking to the next level, double click on each one of them, and then, transport, build a modeler, other things, right, as we move forward. Yeah, this sounds good,
That's good. Thank you, Kobe.
Oh, no problem.
Yeah, next week I will go and look at the Redfish model and let's summarize it.
Okay.
Following week we can really we'll come back with this, all the things needed. Let's summarize IUE.
Okay.
Then once we do both, then we can say here is the delta additional things needed out of systems and racks, right?
Okay. Yeah, I think
we can conclude on that, right?
Right. You may want to, just a pointer. Right. You can publish work week 5, 6, 7, 8. What are the different things you want to complete, like a roadmap of activities? Maybe good idea, right? So
good. Yeah. Very good. Yeah, we'll do that.
Okay. All right. Great. Thank you, and have a wonderful day. No problem. Yeah. Talk to you. Bye. Yeah.